My name's Andrew Thompson. I'm Head of Lifecycle Assurance at Rolls-Royce, which is basically part of our risk management process. And I come from a background of sales, but also supply chain management. So when I look at the strategic problems that we have, I actually see it from both of those perspectives. And as a company, and indeed the aerospace industry, has done a great job of growing rapidly. Air travel for all types, both for individuals, for business and for freight, is a continually growing thing. Businesses are using air more and more for moving their people around, moving their freight and goods around. So it's a great industry to be in from that point of view, and it's one that's seen enormous growth. Rolls-Royce as a company and the people we work with have also seen a great deal of growth. But we're at the point now where, having achieved great sales success, and Rolls-Royce as a company has got a 60 billion order book, it's continued to grow. We are well placed on some major future programs that we haven't yet started to produce in volume, and we're also major players on existing programs. We're at a point now where a tipping point almost, where we need to make a step change in our ability to physically produce the volume of product and get it out there into the marketplace. And we're talking about exponential growth. So we've seen many programs over years where we've been able to win another program which is similar to a previous one or maybe slightly larger, and those build up one on top of another to exhaust and use all of the capacity we have available. And we have plans in place that create capacity to deal with that. We're now at a point where there are so many new programs that we're already committed to that the exponential rate of capacity growth requires quite a change in how we operate. So the first point in our strategy is, I think, from a sales point of view, Rolls-Royce has done a great job, but we've now left ourselves with a huge challenge. And it's a nice challenge to have, but it's one which is not easily solved. If we look at some of the big players in the industry, alongside ourselves, Pratt & Whitney and GE, they're already producing large volumes, but they're continuing to produce large volumes. So if we need to increase our productive capacity, we can't take theirs from their supply chains because they're fully occupied. And indeed, those companies are growing as well as we're growing. There are other players in the aerospace industry, all of whom are growing and all of whom are using all of the effective capacity today. So that capacity has to be created. Now, you can create it internally, but depending on where you're based, that can be very expensive. Now, Rolls-Royce is predominantly in the UK, US and Europe, which are very capable but largely expensive countries to operate in. So, operationally, you take the view that we'd like to create this capacity elsewhere. You have to create it in your home countries as a base point to start the process going forward, but it's very expensive if you try and double the size of the company in relatively higher cost countries. So immediately you start to look overseas to do that. But that capacity doesn't exist today, so we have to be a fundamental part of actually causing it to come into being. And that in itself is very expensive. So whether we are building the factories or whether our suppliers are building the factories, somebody is spending a great deal of money to create the extra capacity required to meet commitments that we've already made. The difficulty that comes with that is that, having already made those commitments in a very competitive environment, they've been made on the basis that you can do all of this expansion at probably a reduced cost per unit rather than increased cost per unit. So you have the dual challenge of saying, we're quite good at what we do today, we think we can get better and lower cost going forward, but in order to meet the very huge demand increases that are upon us, not only do we have to do everything we do today as well, probably better, we also have to create additional capacity, which is expensive to do. So somebody is investing in factories, investing in training thousands and thousands of people, investing in additional supply chains to move materials around, to move whole engines or parts around, investing in making the whole model work against effectively a fixed price base that we committed some years ago. And we're not alone in this. The rest of the aerospace industry is in a very similar position. So if you look to the big airframe manufacturers, they also are expanding rapidly. They're also adding extra models to their product range whilst still producing today's products. Now, when it comes to an airframe, broadly speaking, you're going to assemble it in your own facility because they're such physically large things and it's such an exact science. But more and more, large proportions of an airframe fuselage are coming from the supply chain. So if you go back 20 years, Airbus, Boeing would largely make everything on their own facilities, and they draw it all together and assemble the finished product at one or two sites around the world. Today what happens is they still do the final assembly, but whole sections, complete wings, complete fuselage sections, whole landing gear, tail sections are made in third-party companies and brought together. And all of those third-party companies are having to invest and make bigger and more capable products and factories to produce the volume. But that volume is driven by a real customer demand. More people want to fly, more people want to move their goods around by air freight. So the demand is there for the finished product, the demand is there for the service that is created by manufacturing that product, but the supply chain is not developing, moving on and maturing at the rate and at the cost that's required. So how do you close that loop? That's our first strategic challenge. You have to look overseas, you have to look in your own country, but you also have to look at where the combination of resources can be brought together. So it's relatively easy to build a factory more or less anywhere in the world these days. The vast majority of the utilities that you require, so good quality water, clean air, reliable electricity and gas supply, most of that can be provided in most countries that are industrial or industrialising. But can you bring it all together at a good economic cost to create a factory that can then produce a good unit cost when it's making components, or indeed a good final product cost when it's producing whole engines? And that's a question that I think the jury is very much still out. Now, a lot of people would look at the industry, and indeed aerospace started looking to lower cost economies, China, India, Brazil. Probably as much as a dozen or 15 years ago, people started seriously looking, and in the last 10 years have then started seriously placing work in those countries. A lot of the attraction was the low-cost economy concept, that labour was relatively low cost, and the cost of actually taking over an existing facility and bringing it up to aerospace standard was actually all quite affordable and achievable. That opportunity is all exhausted now. So all the low-cost opportunity has effectively gone, and what you're now having to do is create additional capacity, which at the outset has much of the cost that a Western facility would have. So building a factory in China will be marginally cheaper than building one in Europe. Putting power supplies and gas supplies into Asia will be marginally cheaper than in Europe and the US. And training people is marginally cheaper. And of course the wages and the expectation of people in those countries, very much higher inflation effect on wages than you have in Western Europe and in the US. So actually the attractiveness of going to the lower cost countries as we thought of them is perhaps less there. There are one or two exceptions to that. So great potential in Russia, but it's still a very unstable environment for you to want to invest a great deal of money into. So would we want to invest in factories in Russia? Great opportunity, good engineering background, you can still create something perhaps on an affordable basis, but can you rely on it? And I think that's a great unknown. If you look at Brazil, again, the low-cost opportunity is still there in Brazil because the engineering capability is very good, the ability to create something is very good, but can you actually control the costs, and how reliable will it be in the longer term? A great unknown. But you have to look at both those two, alongside continuing what you're doing in China and enhancing what you're doing in India. India is probably the greater opportunity because their educational base is very high. Their English language skill, which of course is the language of aerospace industry, their English language skill is very high, and the ability to pull together a factory with a workforce, with the utilities and resources that you need, it's still there to do it on an affordable basis in India, but only for a period of time. So if I could turn the tap on and have one tomorrow, great, you could do it in India and you'd start to solve some of the problem. But by the time you've made the decision to do it and you've put in place all of your own resources and you start to pull together the resources in India, for example, let's say if we made a decision today, it would be fully operational and doing what we wanted it to do in 4 to 5 years. 4 to 5 years from now, our problem is even greater than it is today, and the opportunity window has started to close because people's expectation of wages and the availability of resources at affordable cost, that opportunity starts to diminish as well. So aerospace has a real problem. And part of that is driven by the fact we are a genuinely global industry in the way that things happen. So the human resource element, the cost of that human resource starts to normalise over time because we need everyone to be qualified and capable to the global standard because our products are regulated to a global standard. the materials that we put into our finished products are extremely high technology. Whenever you create a new product, you put the very leading edge materials into it, and those are bought globally at a global price. It doesn't matter if you're going to use them in India, they will, broadly speaking, they will cost whatever the global price for that commodity might be. And let's not put aside that if that global commodity happens to be manufactured in Europe or in North America, where most of the high-tech materials, or perhaps Japan, you have to move them from their point of manufacture to the point of use, and you have an extra logistics cost which you might not have if you chose to use them close to their point of manufacture. So there are those sorts of things to think about. But to create something that's sustainable both from a business point of view but also from an environmental point of view, you're also looking to build new capability with the very best processes. So putting in there the lowest cost of process, the very latest machinery. Those machine tools are global commodities. So the fact you happen to be using it in India, it has no lower cost than if you were going to use it in the US, the UK, Japan. The machine tool will cost basically the same. And one shouldn't forget that if you put a very complex machine tool into an industrializing country, the cost of supporting that machine tool could be very expensive, because the in-country support for a very high-tech 5-axis machine is unlikely to be there. So the support service will come from a Western or a Far East country. So a lot of the things that might attract you to set up capacity in a low-cost country, very quickly you see that the window of opportunity to create what is very much required, a volume of capacity at an affordable price against commitments we've already made, that equation gets very, very tight and very difficult to do. You could take the simple option. You could say, okay, what happens is we'll stick in the countries that we know well, we'll replicate our existing supply chains and we'll stretch those as far as we can, and you end up with a diminishing margins business. It would still be profitable, it would still be predictable, very safe and reliable thing to do, but it restricts just how much you can expand. So I think the biggest single issue is how we create all of this capacity at a price or a cost to us that's affordable given the economic equation we've already set in place with commitments to our external customers. And that's the same for everybody in aerospace. Even where you might look at one particular, in our case an engine program, where a replacement product is coming along, the service and support supply chain supporting that existing program will already be vast. So if you look at the next generation of 150-seat aircraft, so Boeing and Airbus have both said they're going to create effectively a substantially warmed over new product. So the old 737, the old A320 family, but with the very latest technologies injected into those. All of the supply chains that might support these new products are already supporting the old products and will be for 20 or 30 years supporting the aftermarket elements, so spare parts, overhaul and service around those old products, of which there are many thousand in service. So if you're also going to then create a completely new family of products, there's a limit to how much you can stretch an existing supply chain to be able to do that. So even those companies are having to find new supply chains. And interestingly, of course, Airbus now assemble their finished A320 family in China. The current generation of aircraft. The new generation, I think, will largely be assembled in Europe, but over time that family could also migrate to China. So there's a tactical thing that's going on there, but it's creating their resource around the physical size of putting something together like an airframe. But of course they've had to train all of the people, and although it's creating something that has an element of indigenous production to its nature, the costs in the long term are marginally different. So airframers have this challenge, engine manufacturers have this challenge, but then when you get into all of the other ancillary things, the industry tends to focus around the engine and the airframe, and it forgets about the seats and the toilets and the galleys and the tyres and all of the other things which have to be produced to aerospace standards to support the industry in the same way. And all of that expansion needs capacity to deal with it, and all of it has to be to the same highly regulated standard. And it's not clear where that will come from. That's not to say it can't be created, but can it be created at an economic cost to the manufacturers that will make them money on the commitments they've already made? If they're unsuccessful, clearly over a period of time, they're all large companies, you can sustain some squeezing on margins, you can find ways to deal with that problem. But what also then happens is you stop generating sufficient profits to then fund the next generation of development. And the big driver behind aerospace development at the moment is purely environmental. So why people are buying the next generation of aircraft now is because they're more environmentally efficient than the ones that they're replacing. And if a commercial airline has a typical 25-year life cycle, you can see that you need to be thinking about the next generation, not just the ones that are already announced, but the ones beyond that. And you need to create funds to come up with a new product, to design it, which is billions and billions of pounds, to design the next generation of aircraft, which will be another step on in efficiency and environmentally beneficial. It gets to be a very exciting race, but an increasingly challenging race. And you then start to compete with other industries that people might find more attractive. So aerospace and advanced engineering is a very attractive place to be, but if you're not making the margins, if you're not an attractive business proposition compared to other things, people might start just, for example, going back to agriculture because you can make as much money being a farmer as you can be making aircraft. Now, we're not there today, but you could easily get there if advanced manufacturing margins are squeezed and the demands for food continue to increase. You might get to a basic trade-off between, do I want to plough up this field and create a new aircraft factory, or do I just want to carry on growing food there?